So there are around 118 elements on the periodic table, and I say around because some of them haven't been decisively observed yet. They're very unstable, so they break down really fast before people have the chance to observe them, and more can be discovered. But there are around 118. But not all 118 are in us, living things, or in human beings. In human beings, only around 20 of them are absolutely essential. And the truth is, 96% of our body is made up of just four: oxygen, carbon, hydrogen, and nitrogen. You can see these here. The ones that are most common in our body are in the red boxes, then slightly less common are in the blue boxes, and still present but very uncommon in much smaller quantities are the purple boxes. Notice that we have the most elements at the top of the periodic table, and as you go down, you get fewer and fewer elements in our bodies until you have none at all. There's an interesting reason for this. All of these elements, this is sort of, if you wake up on Christmas morning and you have a Lego set, it's a Lego set to create the whole universe. These are all the pieces in that Lego set. But how did all of these different elements come to be? They come to be in the center of stars. The difference between hydrogen and helium is the number of protons in the nucleus, and that's the number on top of these boxes. So hydrogen has 1, helium has 2, lithium has 3, beryllium has 4. That's what make those elements the elements that they are. But in the center of stars, there's so much heat and pressure that it can start fusing the number of the protons in different atoms together. If you fuse two hydrogen atoms together, each one brings one proton with it, and you get a total of 2. So the two hydrogen atoms fuse and turn into helium. Helium is a clear gas, but fuse 2 of them together. Each one brings 2 protons with it. Together they'll have 4, and they become beryllium, a solid, shiny metal. And so on and so forth. Take a beryllium atom, which has 4 protons, and smush it together in the middle of a star with a helium atom, which has 2, and you get a total of 6. So that you create carbon. So all of the elements are created in exploding stars, in the heat of stars. Now that includes all of the elements in our body, everything, the atoms in your fingernails, in your hair, the atoms that make up the saliva in your mouth, were all created in exploding stars. But it takes more generations of stars to start to smush more and more atoms together. You can just get one star and start one star exploding and make all these elements in the first 2 rows here. But to make the rows further down, you would need another generation of stars to start smushing these together, and the 3rd generation of stars to start smushing these together to get these higher ones down here. So there's less and less of these elements in the universe as you go down the periodic table, because it takes more time and more exploding stars to smush enough protons together to get these gigantic numbers that you see toward the bottom. So the atoms on the top of the periodic table are more common in the universe, they're more common on Earth, and that's why they're more common in the living things that evolved on the surface of the Earth. Okay, so what role do all these have? Well, it's outlined in a very convenient way in Table 4.4 in the book, and let's explore some of these through problems 7 and 8 in the homework. So 7 says, using Table 4.4, identify 2 things. First, the function of each of the following elements. And then the second thing is we want to classify them. What region of the periodic table are they in? Are they alkali metals, alkaline earth metals, transition elements, or halogens? So let's start with calcium. Now this solid metal doesn't look like something that would be floating around in our body, but it is. Let's look at the elements here. We're going to go down until we see calcium, Ca. There's 1,000 grams of it. That's 2.2 pounds of calcium, that metal that we just saw in our body. Now, the first thing you'd want to write down is the function that it fulfills. It's needed for bone and teeth, muscle contraction, and nerve impulses. So you can copy that exact sentence, just write that sentence down. That's what that metal is doing in your body. The second thing you want to do is to say what region of the periodic table it's in. Now, calcium is right here. That is an alkaline earth metal. So that's the second thing you'd want to write down, alkaline earth metal. And so that's what you would do for A. For B, iron. Iron is this dull, heavy metal. Surely that's not in our body, that metal. It is. So we'll go to the major elements, we'll look for iron, and we have it right here, iron. There's around 3,600 milligrams. It's around 3.6 grams, maybe the mass of like 2 3/4. It's as heavy as around 2 3/4, that much iron. What is it doing? This is the first thing you'd want to write down. It's a component of oxygen, of the oxygen carrier hemoglobin. Hemoglobin is a protein that's in all of our red blood cells, and inside of that, inside of each hemoglobin, there's an iron atom that the oxygen that we breathe in sticks to, that lets our red blood cells carry the oxygen to all the tissues in our body. So you could just write down the function that it has here, and then we want to classify it. Iron is Fe, which is right here. You could see that that is a transition element. These are called transition elements in this valley area because you're transitioning from the left to the right side of the periodic table. C, K, this shiny metal, different metal. K is potassium. And so we're going to look for K here, and potassium K, there's around 120 grams. That might be close to around 1/4 pound of that metal in our bodies. What is it doing? First thing you want to write down as the answer to this problem is, it's the most prevalent positive ion, K+, in cells. It's used for muscle contraction and nerve impulses. The thoughts you're having right now as you listen to this are happening because this ion, that same metal, is flowing into and out of your cells to create nerve impulses that result in thoughts. The movement of your fingers as you write down this sentence on a page is happening because that metal is flowing into and out of your cells. So potassium. Now we also want to classify it. Remember, for each of these things we want to give the function and the classification. So potassium is in this column, this group 1A here. It is an alkali metal. So that's the second thing you'd want to write down. Alkali metal. D, Cl. Cl, this toxic, slightly light green-yellow gas, is chlorine. Surely that wouldn't be in our bodies, but it is. You'd go to the major elements, look down for chlorine. Here it is, Cl. There's about 100 grams of it in our bodies. That's around, that's around 1/10 of a kilogram. So I guess around 1/4 again of around 1/4 of a pound. Now it is so this is the first thing you'd want to write down, is its function. What is all of that chlorine doing in our bodies? It's the most prevalent negative ion, Cl-, in fluids outside cells. And also it's used in stomach acid. When you first eat something, it gets dumped in your stomach, right at the bottom of your esophagus, and in that is this HCl, hydrochloric acid. And that rips a lot of the proteins that you ate apart. There's a lot of chlorine there doing that. We also want to classify chlorine. We can see chlorine is in group 7A, so it is a halogen. That's the second thing you'd want to write down for chlorine. All right, for question 8 in chapter 4, it's a similar thing. So we're going to look, we have for each of these elements, we're going to use that same table, table 4.4, to identify the function that they have in our bodies and to classify them. So first, magnesium. You might walk down an aisle in Home Depot and see strips of this magnesium, and you would never think that would be inside you, but it is. What is it doing? Well, we look on this table down for magnesium, and we would see it right here. There's around 36 grams of magnesium. It's at least the mass of 1/4. What is it doing? And this is the first thing you'd want to write down. It's a component of bone, so it's in our bones, and it's required for metabolic reactions. So it makes things happen on time for us to break food down and to build our tissues up. We also want to classify it. Magnesium is in column 2A. You can see the Mg here, 2A. And so the second thing you'd want to write down, the classification, is that it is an alkaline earth metal. Okay, B, Cu, that's copper. You might see this in some tea kettles or pots, or also in the wires that conduct electricity. That orange solid is in our bodies. What is it doing? We'd go to the table, look down for copper, and we would see here, copper, Cu, there's around 240 milligrams, so not very much, but it is there, and it's needed for, this is the first thing you'd want to write down, needed for blood vessels, blood pressure, and your immune system. So to fight off colds, recover from colds, you would need copper. And we also want to classify it. Now, copper is right here. It's in column 1B, group 1B on the periodic table. And so it is a transition element. That's the second thing you'd want to write down. That is a transition element. C. C is I. That's iodine, which we saw is a dark purple, black solid, or a purple gas, which they sometimes put on a liquid. As a nurse, you would use this as a topical ointment that you'd put on someone's skin to kill the bacteria there and sterilize their skin before you give an injection or take blood, for example. So what is iodine doing in our bodies? That same iodine that you put on somebody's skin is already in somebody's body. What is it doing? We go down on this table. We see that it's right here, iodine. There's around 20 milligrams, so not very much, but it's needed for proper thyroid function. And that's why they iodize sea salt. Iodine is needed for thyroid hormones like thyroxine, which set your metabolic rate. So, for example, those people who can eat like 6 hamburgers and not gain any weight have a lot of thyroxine in their blood, and that is made using, in order to make that, you need iodine. So iodine, where is it? It's right here to the right on the periodic table, and so it would be classified as a halogen. So in addition to writing down the function that we saw a second ago, you'd also want to write down that iodine is a halogen. For D, Na. Na is sodium. Soft metal, you could cut it with a butter knife, explodes when it comes into contact with air. Is that in our bodies? It is. So you'd go down through these elements, you'd look for sodium. What is it doing? It's the most prevalent positive ion, Na+, in fluids outside cells. It is responsible for water balance, muscle contraction, and nerve impulses. And so that is what you would want to write down for the function for sodium. And you'd also want to classify what type of an element it is. You see that Na is in group 1A. So sodium is in group 1A, and it is an alkali metal. And so that hopefully would just give you an appreciation of these different elements that seem so different from living things are actually the components of them. And hopefully these 2 exercises give you an appreciation for what they do in the human body and what type of elements they are in terms of how they're classified.